Aluminium is one of the metallic elements located in group 3 of the periodic table. In this lesson, you will learn about the occurrence and the method employed in the extraction of aluminium. To start with, aluminium is the most abundant metal and the third most abundant element found in the Earth's crust. It makes up about 8% of the Earth's crust by mass. And in its combined state, a significant amount of aluminium is found naturally in some minerals such as kaolin, mica, corundum, and bauxite. Among the minerals in which aluminium can be found, bauxite is the world's primary source of aluminium. Now let's discuss how aluminium is extracted in the metal extraction industry. As mentioned earlier, bauxite is the primary mineral or ore from which aluminium is obtained. The method used for the extraction of aluminium is the electrolytic reduction method, and this is because it is a reactive metal. Since bauxite contains impurities which are mainly iron 2 oxide and trioxosilicates 4, the extraction of aluminium involves two stages, which include the removal of impurities from crude bauxite and the electrolytic extraction process. In the ore purification stage, bauxite is dissolved in a hot concentrated sodium hydroxide solution under pressure. This dissolution leads to the formation of sodium aluminate 3. This process helps to remove impurities from the ore because the impurities in the ore do not dissolve and can be easily filtered off. The sodium aluminate 3 is then treated with carbon 4 oxide to precipitate aluminium hydroxide. Since aluminium oxide is what is needed for the second stage of extraction, the precipitated aluminium hydroxide is heated at a temperature of about 1,200 degrees Celsius to decompose to aluminium oxide and water, as shown in the equation here. The second stage of the extraction is the electrolysis of a molten mixture of aluminium oxide and cryolite in an electrolytic cell. The cryolite is added to lower the melting point of aluminium oxide from 2015 degrees Celsius to 950 degrees Celsius. As electric current flows through the electrolytic cell, aluminium ions in the electrolyte are electrically discharged and deposited at the cathode in the form of molten aluminium, which is then collected. At the anode, oxygen ions are electrically discharged. This results in the formation of oxygen gas. So let's do a quick recap of what we have discussed so far to help you remember the key points. Aluminium makes up about 8% of the Earth's crust by mass. In its combined state, aluminium is found naturally in some minerals such as kaolin, mica, corundum, and bauxite. Aluminium is extracted from bauxite through the electrolytic reduction process. We will wrap up this lesson at this point, and I hope you will plan to return for another. Goodbye.